Hi, I'm Chet Haas, an engineer on the Android team at Google. In a previous episode, I talked about ListView animations where we would remove a view and then animate both the swipe of the item out of the list view as well as the collapse around where the item used to be, animating all the other views into place. So that was all good. You can run that kind of animation on the property animation system that goes all the way back to 3.0. The demo I'm going to show today looks remarkably similar to that, but there's an important twist to it. So first, let's see the demo. If you want to go back and watch the previous show and sort of have some context for that, that's fine. Okay, you're back. Here we go. Let's run the current demo, and this should look remarkably similar to what we saw before. So we swipe an item out. If we swipe it a little bit, it animates back into place. If we swipe it further, it animates out, and then it animates the gap to be closed. So here's the twist. If we run this on Gingerbread, which is on my Nexus S here, you can see the same animation. So this is a question I get a lot with my animation demos is, gee, all this property animation stuff is really cool. How would I do it on older releases? Hopefully that issue is going away over time, but if you are concerned about Gingerbread releases still for your application, then maybe we can see how you could get this kind of technique even on that older release. So let's take a look at the code. I'm not going to go over all the elements of the code, the background drawing and the shadow and everything that was in the previous talk. Just go ahead and check out that other DevBytes as well as the Google I/O animation talk that demo came from. Instead, I just want to focus on the aspect where we're able to run both the new property style animations as well as the older animations. So in our touch listener, we're listening for these swipe events, and we're doing essentially the same thing. We're listening for the down event, and we're tracking where that down event occurs, and then in the move event, we figure out where the new X position is to figure out how far to move this thing. And at this point, you might be thinking, yeah, but we're using translation X. Like we're using a property that doesn't actually exist on Gingerbread. So how does that work? That's the key. Okay, so before we could get the translation X value and we could set the translation X value, and these are view properties that came in 3.0. On Gingerbread, those properties don't exist on view, so it's a little bit difficult to work with them there. So instead, what we do is call this set swipe position. So I refactored the code so that we could sort of do the correct thing on either release, Gingerbread or non-Gingerbread, post-Gingerbread. So in that method, set swipe position, you can see how this works. So if runtime is post-Gingerbread, this is what we did before. We simply set the translation X value. We basically pop this item that we were swiping over to the appropriate place, and then we set the alpha value to be more or less translucent based on how far away it was from the original position or how close to the edge of the screen. If you're on Gingerbread, those properties don't exist. We don't have alpha, we don't have translation X. So what can we do? We can work with the old style animations. This was the animation system that existed prior to 3.0. But we can use that for actually setting these properties and kind of faking the way the view looks so that it essentially looks the same. It's not quite the same because there is no alpha property, but it is more translucent. So it's effectively visually the same thing. So we can set a translate animation on the item, we can set an alpha animation on the item, and we can create an animation set to bundle both of these up. We add both of these animations to the animation set. We set fill after and fill enable to true, which means they're going to hold their value even when the animation is over. And then we're going to start the animation. So basically we set up animations on these things, and we're going to effectively set the alpha and the translation property of this item by running these animations to a particular value. And we're going to run, notice that we're actually running the translation animation basically from the current value to the current value, which means we're going to just slam it in there where it's going to start and end at the same value. And even though the animation is ended, we've set fill enable to true and fill after to true, which means that they're going to stay at that value. So that's the trick to actually not animating the swipe, but actually setting the swipe to be at the right position under the user's finger. Okay, so that's setting the swipe, but then we have the other behavior of actually animating the thing after it's removed. So we come in here and say, okay, when the user lifts up, if they were swiping this item, then we want to figure out how far to move, and then we want to animate the swipe. So we call this other method down here. Again, we've refactored this into a separate method where we either do the Gingerbread thing or the post-Gingerbread thing. Post-Gingerbread, this looks similar to it did before. If you saw that other video, we animate, we use view property animator, we're animating alpha, we're animating translation X. Here we use a listener, so actually this animation will work all the way back to 3.1. There's no dependency on the Jelly Bean API of with end action in view property animator anymore. Instead, we just set a listener, and when the animation ends, then we do the appropriate thing. We restore values, we animate to close the gap, all that stuff. If we're running in Gingerbread, to animate the swipe, this looks remarkably similar to what we saw before where we were setting the swipe position. All we're doing is animating the swipe position now. So we're starting from the current X and the current alpha value from wherever that item ended up, and we're animating either off the screen or back into place. Again, we're using an animation set. We're no longer setting fill enable because we don't want to hold the value when we're done. Instead, we just go to animate off or animate back. And when the animation ends, then we either restore values to where they were if we were animating back, or we animate the other views. And for this one, we want to animate the gap closed. So using the same technique that we used in the previous demo, in the previous DevBytes video, we figure out where all the views are, and we associate those view positions with the item IDs. So we're using a stable ID array adapter here again, and we store these in a hash map. And then we remove the item from the adapter. That forces a notified dataset change. That will force a layout. But before that layout is displayed on the screen, our on pre-draw listener on the view tree observer kicks in, and we can now track the positions of all the views in the current version of the list view and figure out what item IDs those are associated with, compare them to the other item IDs, and animate the changes. Again, all of this is the same as before. The only trick here is how to actually make it work in Gingerbread. So we remove the pre-draw listener, we figure out where things need to go, and then we run the animation, which is right here. Move view runs the animation to actually shift these things on the screen. Again, we have a Gingerbread and non-Gingerbread version of this thing. The non-Gingerbread should look remarkably similar to what it did before, except in this case we're actually using object animators. Sort of interchangeable with view property animator. View property animator is a little bit more of a streamlined API. I happen to use object animators in this case. In the Gingerbread version, again, we're using a translate animation, pre 3.0 APIs, and we're saying, okay, I want this view to move from the current start and end X and Y positions, and those were calculated according to where the item contents were before and after the layout change on the list view. And we set the duration, and we start the animation. And that's it. Really fairly straightforward. The only trick was that the old approach was using properties that didn't exist on view prior to 3.0, so we can't use that. So we use the old animations instead to fake the system out and make it look the same. And then the animations, same thing. We were using animation APIs based on properties, didn't exist prior to 3.0, so instead we'll use the old animations that didn't use properties, but give the same visual effects to what we were doing. Everything else is the same logic. Track the item IDs before and after, where the views associated with those item IDs were, and then simply animate the changes. And that's it. So go ahead and check out the animation talk called A Moving Experience at Google I/O to get a little bit more glimpse into how the demo actually works and the reasons behind it. And check out the other DevBytes videos to see the overall structure of the code and some of the other elements I didn't talk about today. And check out the code for this demo. Thanks.